Welcome to Saxon Math Course 3, Lesson 106, where we will be reviewing the effects of scaling on volume. Now, remember that when we are finding volume, we use our dimensions. If we had a rectangular prism, it would be length and width and height. And what we would do is we'd multiply them together as length times width times height. If we apply a scale factor, such as 2, to our dimensions, we would multiply each dimension by 2. So we'd have 2 times the length, 2 times the width, and 2 times the height. If we find the volume with a scale factor of 2, we would have 2 times the length times 2 times the width times 2 times the height, which would give us 2 times 2 times 2 times the length times the width times the height. All I've done here is I've moved all of the numbers to the left-hand side, all the variables to the right-hand side using the commutative property. And now we can simplify 2 times 2 times 2. That's 2 to the power of 3. And then we have length times width times height. Now what we can see here is that our volume will be our scale factor cubed times the original volume. Which we saw up here. We can use this in any sort of problems. It doesn't have to be a cube. Anytime you're finding volume, the ratio between the two volumes will be your scale factor cubed. So what we say is that volume times scale factor cubed will be the volume after we've applied the scale factor. Now there's one example, and then we're going to go into the practice set. So example 1 says a large brick has 1.5 times the dimensions of a small brick. What is the ratio of the volume of the large brick to the small brick? If they are made of the same material, how much does the large brick weigh? Well, all you'd have to do is take the scale factor and cube it. The scale factor is given to us as 1.5. 1.5 cubed is 3.375. Then all you have to do is take the original weight, which was 3, and multiply 3 by 3.375. When you do that, you'll get 10.125 pounds. Now, that would have been the end, but we're going to go through our practice set as well so you guys can see a couple more examples. We need to get some more practice with it, so we're going to do the practice set. Now, our practice set A says a 3 by 3 cube has 27 blocks. How many blocks are needed to make a cube with dimensions that are twice as big? Well, remember that the ratio of the volumes is the scale factor cubed. If the dimensions are twice as big, the scale factor is 2, and 2 to the power of 3 is 8. So you do 27 times 8. 8 times 7 is 56. 8 times 2 is 16, plus 5 is 21. So it would be 216 blocks. Question B says, an architect builds a 1/50th scale model of a building. The volume of the model is what fraction of the volume of the building? Well, we would take 1/50th and multiply that by itself 3 times because it's to the power of 3. So 1/50th times 1/50th times 1/50th. 1 over 50 times 1 over 50. 50 times 50 is 2,500. And 2,500 times 50 would be 125,000. For practice set problem C, it says a scale factor of 1.25 is about what percent more? Now remember that percent more means we're going to take the percentage it would be and subtract 100. So if we have a scale factor of 1.25, which is 25% increased, then we're going to do 1.25 to the power of 3, which is 1.953125. Now if we subtract 1.0, which is 100%, we'll get 95.3125%. And that's 95.3125% more, and this was a multiple choice practice set problem, so we're going to say that that's about 100% more, which is C. If a crate will hold 24 cubes with 12-inch sides, how many cubes with 6-inch sides could it hold? Well, if we put 12 over 6, that's a scale factor of 2. So we'll do 2 to the power of 3. 2 to the power of 3 is 8, and then we will do 24 times 8. 24 times 8 is 192, which means it will fit 192 cubes. This has been lesson 106. Make sure you do all your homework, stay safe, stay inside, and do something fun today. Be nice to someone.